Okay, so this is your last method for chapter 1. Okay, we're learning no new methods after this. This is it. Okay, so this last method, guys, I'm not going to talk over you. Please stop. Okay. This last method is called method of pairwise comparison. So in other words, we're going to pair everybody up and compare their points. Okay, they also call this Copeland's method. So your method for pairwise comparison, these are head-to-head competitions. Okay, head-to-head competitions. And these are in pairs, which means 2 candidates. So this is probably the one that will take the longest out of all 4 of the methods that you've learned in this chapter. Okay. So when we complete this method, complete a pairwise comparison. Points are awarded to the winner. So if my 2 candidates are going head to head, and it's Cozy and Josh, and let's say Josh wins, okay? If Josh is the winner, he gets 1 point. If Cozy's the loser, he gets no points. If the 2 candidates actually tie, they each get half a point. Okay. There is a chance for people to tie in this one.
What is it, 0.5 instead?
0.5 or 1/2, it doesn't matter. Okay. So if you want to think of this as 0.5 points, that's fine as well. Okay. 0.5, 1/2. All right. So the first thing you need to do is you need to list out everybody that has to play everybody. Everybody plays somebody once. Okay? So, A has to verse everybody. So, they need to pair up and face off against B. They need to pair off and face up against C. And then they need to pair off and face up against D. So at this point, A has played everybody that is there. We need to do the same for B. Okay? We don't have to go back and verse A. We've already done that. So we just move forward. So B has to play C, and they have to play D. And then finally, C has to play D. Because they've already played B and they've already played A. Okay. Now, we have to do each one of these comparisons individually. That's what takes the longest. Okay. So, we're going to look strictly at this one first. A versus B. So, you're going to look at each one of these columns. What comes first, the letter A or the letter B in that first column? A. So this one goes to A. Your second column goes to A versus B. Okay, pretend nobody else is there. So B would take that column. It takes B takes this column, and this column.
Why take yours?
Right.
Because
it came before A.
Okay, so when we're doing the A-B comparison, it's like C and D doesn't exist. So you need to look at each column just in comparison of A and B. Okay, so the other candidates no longer exist.
Right.
So A comes before B comes before A, so on and so forth. Does that make sense now?
Yes.
Okay. So A gets 14 points and B gets 18, 22, 23. So comparing A and B, who wins?
B.
B. Okay. We need to do that now with A versus C. So again, when we look at A versus C, it's like B and D don't exist. Okay, A versus C, it's like B and D don't exist. So A takes the first column, C takes the rest. So who's my winner here, A or C?
C.
C's gonna take this one. And finally, A and D, it's like B and C doesn't exist. So D is my winner here. Okay, now we're looking at B and C. So A and D don't exist. It's a lot easier because I can erase it a lot easier up here than it is for you to do it at your seats. Okay, so when we compare B and C, B actually takes this column and this column, which gives them 18 points, and C has 19. So C is going to take that one. B versus D, so A and C are out. So who takes this one, B or D?
B.
This one goes to B. And my last one, C versus D.
C won there.
C wins that one? All right, perfect. So now that you've looked at each comparison, now we count up total points. Every time I've circled something, they get a point. How many points does A have now?
0.
0. They didn't win any. How many points does B have? 2. C has
3.
and D has
1.
Okay. If you count all these points up, how many matchups did we have total up here? 6. This should always equal that amount of comparisons. So if we had to pick a winner right now, my winner is going to be C. Now that I've explained it, does it make a little bit more sense than Friday?
Yes.
Question. All right. Take a look at example 2. The smaller the charts and the less candidates we have, the easier that this is. So I only have 3 candidates this time. So I've got to do A versus B, and A versus C, and B versus C. There's only 3 comparisons to do this time. Okay, when you compare A and B, okay, so we pretend that C no longer exists. What happens with A and B? It's a tie. Both of them have 17 points. So that means that they both get half a point. Okay, when I compare A versus C, which means B does not exist. A is going to take that one. And when I do B versus C, where A does no longer exist, you said B takes that one? Yes, 22. Okay, so when I count these up, A actually has 1.5, B has 1.5, and C has nothing. Again, there were 3 comparisons, so when I add up all 3 of those totals, that should equal 3. Okay, so here we actually have a tie. A and B tie. Okay, so that leads me to my third fairness criterion. It says if candidate X is the winner by the voters over each of the other candidates in a head-to-head competition, then candidate X should be the winner. So, in other words, if your candidate wins every matchup that they're in, they're called your Condorcet candidate. Okay. But they have to win every matchup. So if we actually go back to this example, okay, how many people does each player have to face? If I have 4 people. Somebody said it. 3. Okay. If there's 4 candidates, each candidate has to play 3 people. Does anybody here have 3 points? Yes. So C is not only your winner, they are also your Condorcet. Oops, I can spell today. That does not look like an N. Okay. C is also your Condorcet candidate. So they've won, and they won every match that they were in. So they are your Condorcet candidate. If you look at example 2, do we have a Condorcet candidate in example 2? No. Okay, in order to win example 2, you would have had to have 2 points to be the Condorcet candidate here. Okay. All right. So here's a quick and easy way to figure out how many candidates you need. Friend, don't make me take the phone. Come on now. Okay. In the first example, we had 6 comparisons we had to do. In the second example, we only had 3. Okay. We need to figure out how in the world do I figure out how many comparisons I need. So if I have 2 people, how many matchups do I need? 1. Okay. We said if we have 3, we need 3. And if we had 4, we needed 6. Can anybody figure out the equation? Because as always, there's an equation. You know it? Oh, wait, most of you should. You watched the video, right? Huh? They were a little bit different. Because I changed up the notes this semester. I forgot about that. All right. So, to find out how many pairwise comparisons you need, it's your number of candidates times 1 step below that divided by 2. So 2 times 1 divided by 2. So the second one, 3 times 2 divided by 2. Four times 3 divided by 2. which means how many comparisons would we have for 5?
Is it always gonna be divided by 2?
Always divided by 2.
10.
10. You would do 5 times 4 divided by 2. So we've got 10 comparisons to do. And we've got 15. Again, 6 times 5 divided by 2. Oops. Okay, so there is always a way to figure out how many comparisons you need. That way you can always count them and make sure you have enough. Okay, because that's going to be your biggest downfall, is making sure that you have every comparison written there. If you also notice, another way that I use, A versus everybody is 3. The next column should go to 2. The next column should go to 1. So if we start with 4 comparisons, it should then go to 3, to 2, to 1. It always goes down each time when you start with a new candidate. Okay? So keep that in mind. All right, so your number of pairwise comparisons. It's always the number of candidates. This is the formula we just did. Number of candidates times 1 less divided by 2. That's your formula each and every time. So if I told you that we have 7 schools that make up the Piedmont Triad Conference, how many pairwise comparisons exist? How many comparisons exist if we start with 7 schools? Okay, so 7 times 6, which is 42, divided by 2, 21 pairwise comparisons. If I have 27 candidates running for office, how many pairwise comparisons exist? 27 times 26 divided by 2, 351. No, you will never, ever have to do 351 pairwise comparisons. However, you may need to use that formula to come up with that number.
Yeah, this was
Okay, glad I skipped those ones. All right. Example 3. Oh, last 2. We're almost done. Okay. Example 3. A coaching staff is considering drafting football players with the following preference schedule below. Who should the team draft? How many comparisons do I need for this one? How many total should I have?
no 5 times
10.
4.
There should be 10. I've got 5 candidates, so 5 times 4 divided by 2 means I should have 10 listed. So we've got A versus B, A versus C, A versus D, A versus E. Okay, so your first one starts out with 4 comparisons. So then when I start with B, there should be 3 here. B versus C, D, and E. There's 7. My next should be my C comparison, so C versus D and E. And finally, we finish off with D versus E. And again, if you count those all up, there's a total of 10 there. So if we look at the comparison of A versus B, who's going to take A versus B? B takes this one. You said A takes what? A takes the other 3. Okay? A is going to take the other 3. You said C takes the next one.
Then a tie.
Okay, then a tie.
Then
I always put 0.5 over top of the letters when there's a tie.
B.
And then B wins. Okay. And then we've got
C.
C, E, and then D. So when we finish out with all the points, A has a total of 3, B has 2.5, C has 2, 1.5, and 1. So A should have been your winner here. Questions on that one or where any of that came from? Was the last example on the video too? Yeah. Okay. So all we did here is we took out C. Okay. So which matches from the original pairwise comparison remain? Everything but C. We took out your C candidates. So do the results of those remaining matches change? No. Okay? They don't change at all. So, in other words, all we really have to do is go back here and get rid of everything that had C in it. So we get rid of this one, and both of these. Comparisons that had those. And then recount. So, now that we recount, A is now down to 2 candidates, or 2 points. B now has 2.5. That one didn't change. C is out. D now has 1.
0.5.
Oh, sorry, you're right. 1.5. It didn't change. And E now has nothing. Okay. So when that happened, A has now lost its ranking. B is now in first place. So B is now your winner. Okay. So do you think it's fair to all the coaches once C dropped out? No, because now we've got a new winner. Okay. So that brings me to our last fairness criterion. It says if candidate X is a winner of an election and a recount, one of the non-winning candidates is removed. Then X should still be the winner of the election. So we removed a candidate that didn't win to begin with, but somehow that magically made our winner change, which caused a problem. They do shorthand this to the IIA criterion instead of calling it the independence of irrelevant alternatives. That's a big mouthful. Okay. Any other questions? Okay. So,
Sorry, Ms. Fisk, can you give the name for the homework that was due Friday? So
Yes.
At the bottom.
all right. So, fair voting. Fair voting is only when all 4 fairness criterion are satisfied. Unfortunately, that's 100% impossible. Okay. It's never going to happen, which is why we have such debates with our elections, okay, and everything going on. It's not on the bottom.
No.
Dang it. It might be all, yeah, you're right. It's all
Yeah,
back.
it's like a- come on.
Okay. Sorry.